Hello students, you are welcome to Career and Skills Development Center, in short known as CSDC, which is located at Kharghar. Today we will start first chapter of the science subject, namely chemical reactions and equations. Before we start this topic, I would like to inform you that you have to be very sincere and loyal in your studies, as this is very crucial year in your life. Not only from getting good percentage in 10th standard, but in case you want to get good percentage in 12th and get admission in the professional college in which you are interested, then 10th standard will build a strong base for you to fulfill your dreams. So you have enjoyed so far, but now this year you have to be very loyal and sincere in your studies. I understand that due to lockdown, many classes were held online, so your understanding might not be full. So I will revise the necessary concept which is required for understanding 11th standard topic at that point. Now let us begin today's chapter, chemical reactions and equations. Before we start this chapter, I will be writing syllabus of that chapter in the beginning. So for this academic year, the chapter 1 syllabus reads chemical reaction. So you should know everything. What is a chemical reaction? How chemical reactions are written in the form of chemical equation? How to balance the chemical equation? Implications of a balanced chemical equation means what does the chemical equation tells us? Then various types of chemical reactions which are listed: combination, decomposition, displacement, double displacement, precipitation, endothermic, exothermic reactions, oxidation and reduction, and also a bit of its application, like what is corrosion and what is RANACIDITY. So these are the syllabus points that you should have to study. So we will start with first now chemical reactions. Now before starting with chemical reaction, first let us try to understand, which I think you have done in 9th standard. You might be seeing the various changes in nature in your day-to-day life. For example, you might be seeing that iron products are getting rusted, especially in monsoon. Milk, if kept outside the refrigerator for a long period of time, especially in summer months, it becomes soft. You might be you are respiring many times. The food is getting digested. If you keep the ice outside, it becomes water. When I keep water on the stove, gas stove, it turns into vapor after some time. So what are these changes? So these changes are divided into two groups. One group is called physical changes, other group is called chemical changes. Like physical group means in case I reverse my conditions, I will get the same thing back. Like if you have kept the ice outside the refrigerator, it melts into water. You keep that water in the refrigerator, it will again become ice. So this is a physical change. Now what about iron rusting? You will see that brown color powder is there. So Now that brown colored powder will never turn into iron, whatever you do. So this is a chemical change. Milk becoming sour is a chemical change because due to oxidation, means reaction with oxygen from the atmosphere, it gets converted to lactic acid, and that with this acid makes you feel that milk has become sour. So this is a chemical change. The food that we eat in the stomach, various chemical reactions take place and the food gets digested. It becomes into the liquid form, which gets then absorbed in the intestine and goes in the blood, and fibrous material comes out. So it is a chemical change. Respiration. What is respiration? It is that the glucose which is in the blood reacts with the oxygen which you breathe, and due to oxidation of glucose it becomes carbon dioxide and water, and which you are exhaling out. So this is also a chemical change. In case some crockery drops down from the hand, it breaks into pieces. So this is a physical change, because no new product has formed. In a chemical change, after the change the product is something different from the earlier one, and you cannot get the same product. So is it alright what are physical changes and what are chemical changes? So today, whatever changes you observe, you think whether I should classify this as physical change or a chemical change. Okay, so chemical change we say take place due to chemical reaction. Means when two substances or more substances interact with one another, they form other products. Even when there is a single product, if you heat it, it may also break into simpler parts. That is also a chemical reaction. So in chemical reaction, the substances or the molecules that react and get changed are called reactants, and the new molecules which are the new substances which are formed, they are called products. So this word you should learn. What is reactant, what is product? Reactant means chemical substances or molecules which react with one another and form a new substance. They are the reactant, and the new products which are formed, they are called products. Okay. Now, if you take a magnesium ribbon and you burn in flame, dazzling white flame will come. During Diwali time you might have burnt this. Okay, and you will find that after some time you will see that some powder has fallen on the floor. So magnesium has got converted to a powder, white powder. That white powder is nothing but magnesium oxide. Magnesium has reacted with oxygen from the atmosphere and has formed magnesium oxide. So this is a chemical change. You might have studied that all matter is made up of atoms and molecules. Molecule means it is made up of two or more kinds of atoms. Atoms may be similar or it can be different. Like in case we take nitrogen gas. One molecule of nitrogen gas is made of two atoms of nitrogen. But if we take ammonia, it is made up of one atom of nitrogen and three atoms of hydrogen. Water, you know very well, is made of two atoms of hydrogen and one atom of oxygen. So, when a chemical reaction takes place, what happens? There is a rearrangement of atoms between the two or more molecules which are reacting. or they break into two groups or more groups. We will study that what are type of reaction. So this is the reason for the new products that form, that there is a rearrangement of atoms is taking place. Therefore, in reactants and in product, the number of atoms which are in reactant are in product of each type. Suppose in reactants there are 5 atoms of hydrogen, in product also we should have 5 atoms of hydrogen. In reactants there are total 3 atoms of sulfur, then in product also there should be 3 atoms of sulfur. But sometimes when we write this equation, we may not get exact arithmetic. So we say that equation is unbalanced. We can balance that equation. That we are going to study next time, how to balance the equation. Okay. So now this is a sort of a revision. We should learn that during any chemical reaction, atoms are conserved. Means if in left hand side there are 4 atoms of hydrogen, right hand side also will have 4 atoms of hydrogen. And whenever a chemical reaction takes place, either energy is released or energy is absorbed. If the energy is released, the thing will become hot. So we will say it is an exothermic reaction, and in case it is absorbed, we will say it is an endothermic reaction. Is it alright? Then the substances that are taking part in the chemical reactions are called reactants, and the new products formed are called products. Now this, instead of writing in description that substance A reacts with substance B and then they form substance C and substance D at this temperature and so on. So we have formed a convenient way of writing this, which we call an equation. I will show you the equation today itself. Okay. So you can see here. See this equation. See this equation written here. Burning of magnesium. So forget about this 2 first. Magnesium plus oxygen is forming magnesium oxide, which is white powder. So so my reactants are magnesium and oxygen, and product is magnesium oxide. Now I have balanced this equation because all gases, oxygen gas is having one molecule having 2 atoms. So we have to write O2. Magnesium is having only 1 atom in this molecule. Magnesium oxide is having 1 atom of magnesium and oxygen. But then balancing will not take place. So to that balancing, I have to write 2 here. Now magnesium got 2. And here also not to get 2 magnesium, I have to write 2. So 2 magnesium here, 2 magnesium here. So magnesium atoms are balanced. Oxygen 2 here, this 2 and O 1. So it becomes 2. So oxygen is also balanced. This is called balancing. How to do this balancing, I will explain to you in the next session. Is it alright? So this is called a balance equation. So instead of writing in a sentence form that when a magnesium ribbon is heated, now I will explain to you when we are heating, so we can put a triangle here. That indicates that we are heating. If we put a triangle above the arrow, it indicates that we are heating. This is the sign for that we are heated. And sometimes we even write the temperature here or pressure here to indicate the conditions. So when magnesium is heated in atmosphere, we are getting magnesium oxide. So this we will learn in some more detail also that what are the various information this equation gives us. Okay. Now, sometimes you may find that magnesium ribbon is not burning or it is burning very slow. Why? Because that magnesium, if this is the magnesium ribbon, this is the magnesium ribbon. Okay, then what is happening? happening. This is my magnesium ribbon. Outside, all along this outside, magnesium has reacted with oxygen and moisture, and it has formed magnesium carbonate and magnesium hydroxide. So now oxygen from the air is coming in contact with magnesium hydroxide and magnesium carbonate, which we call it basic magnesium carbonate. So my atmosphere oxygen is coming in contact with basic magnesium carbonate, so reaction is not taking place. So if I rub this external surface, clean the external surface, and then you will see that the magnesium ribbon will burn, and that. Is it alright? So that is why with sandpaper we sometimes clean this magnesium ribbon. Now I will show you the various changes that are taking place during chemical reaction with help of few examples. So my first example is that you take some zinc granules in a conical flask. You know what is a conical flask? Conical flask is of a shape of cone like this, and so here I am taking my zinc granules. So these are my zinc granules with small pieces, and here I will keep a funnel. From the funnel I will add dilute sulfuric acid. So add dilute sulfuric acid to zinc granules kept in this conical flask. So what will you observe? That zinc will react with sulfuric acid. Sulfuric acid is written as H2SO4 and will form zinc sulfate plus hydrogen gas. Hydrogen gas is coming out, so to show gas, one method is to show the arrow up or to write G in the bracket. So zinc sulfate is solid, this is liquid, so we need not add anything, zinc is solid. Sulfuric acid is liquid, so we can write that. So zinc plus sulfuric acid will form zinc sulfate, and this is in solution form, so it is in a liquid form. Okay, so zinc reacts with dilute sulfuric acid. We can write here DIL in bracket. That this is my dilute sulfuric acid. Form zinc sulfate and hydrogen gas is given out. So this reaction shows that during chemical reaction sometimes gas is given out. And if I touch this flask, it will become, I will feel it hot. So heat is also evolved in this reaction. So this is called exothermic reaction also. Now when dilute sulfuric acid, dilute hydrochloric acid, HCl, is added to sodium carbonate, then sodium will form sodium chloride, and hydrogen and carbonate will form water and carbon dioxide. So I will see my carbon dioxide gas is coming out. So when I add dilute hydrochloric acid to sodium carbonate, carbon dioxide gas comes out. So again, this is an example showing gas is coming out. Then this is very important. Next, if I take potassium iodide, this is potassium iodide solution, and I am adding to lead nitrate, then what will happen? Lead will combine with iodine, so I will get lead iodide and potassium nitrate. Now lead iodide is yellow color solid particles like common salt particles, but it is yellow in color. So lead iodide will settle down in the bottom of the test tube, and you will indicating that chemical reaction has taken place. So whenever a precipitate gets formed, means some chemical reaction has taken place. Next, if I add dilute sulfuric acid to barium chloride, similar thing will take place. Barium sulfate will get formed, and barium sulfate will get formed along which will be in the form of a precipitate. Barium sulfate is but white color precipitate. So I will get barium sulfate, and this hydrogen and chlorine will form HCl. Important is that barium sulfate gets formed, which is in white precipitate. Now if I add citric acid, lemon juice, to purple color potassium permanganate, then I will see that my solution has become colorless. So during chemical reaction, the color thing becomes colorless. It may become colorless. Then SO2. So whenever anything we find is becoming colorless, means some chemical reaction has taken place. Now if I pass sulfur dioxide through orange color of acidified potassium permanganate. What do we mean? Acidified means I have added small amount of sulfuric acid to potassium permanganate, which is orange in color. If I pass SO2, it becomes green. So there is a change in color. So these examples indicate the changes that we are observing during chemical reactions. Now next example. If I take quicklime is nothing but calcium oxide. If I take quicklime in a beaker and add water, I will find that it becomes hot. So as heat is evolved, it is called exothermic reaction. Similarly, now if I take barium hydroxide and add to ammonium chloride solution, so I am adding to ammonium chloride, so what I will get? Barium chloride and ammonium hydroxide. Okay, but now I will find that my beaker or test tube has become cold. So means heat has been absorbed. So this is an endothermic reaction. So you should learn. Sometimes they ask in exam, give an example of endothermic reaction, give an example of exothermic reaction. Then, so from above reactions, what we can conclude is the evolution of gas, or the change in color, or the change in evolution or absorption of heat is taking place, precipitate is getting formed. If we are observing any of these changes, it means some chemical reaction that take place. One or more can also take place. Is it all right? So this completes this topic. Now I will give you some sort of a homework type, because we have studied in the previous class. The metals have 1, 2, 3 or 4 electrons in their outermost orbit. To get into the more stable condition, they want to lose those orbits. So number of electrons that they want to lose, that is called as valency. So all these 4 metals, 3 potassium and sodium are 2 metals which want to lose. So plus 1 hydrogen, it also has got valency plus 1, and ammonium is called a radical because it is made up of nitrogen and hydrogen. So just learn that these 4 elements or radicals have got valency plus 1. Then first you learn for positive. Now you see for 2, you learn magnesium, calcium, barium, zinc. They have got 2. And 3, aluminum and chromium. And in the next slide I will show you that 4 is for carbon and silicon. So first learn for 3 and 4. These 4 have got 2 and other 4 have got 1. So I am giving you only important ones which you will be requiring in the 10th standard or 11th standard. Now for negative you have to study law. Now this as such, fluoride, chlorine, chloride, bromide, iodide, all these 4 are called a family of halogens. So they have got valency negative 1. Hydroxide -1, nitride and nitrate -1, valency -1. You first learn up to here. that would be adequate fluid. Is it alright? Then for negative 2, what we done? All with SR2 and all with 8R2. So sulfide, sulfate, sulfide, carbonate, silicate, zincate, chromate, dichromate, oxide. You learn up to here. So they have got 2, their formulae are written here. Then 3, there are only 3. Phosphide, phosphate and nitride. So you learn these tables, valencies. This you can learn afterwards, and this I explained you, carbon and silicon are metals having 4. So learn these valencies and the formula of these radicals, and come next time so that it will become fast to understand balancing of equations. I hope you have understood this topic which I have explained you. So revise it thoroughly, and learning of balances is very important because it will be required till you are studying chemistry. In case you have understood and enjoyed it, then subscribe to the channel and press the bell icon so that you will get notification when my next video is posted. You can also like the channel. Thank you.